Welcome to everybody. Uh, so, what is the linear differential equation with constant coefficients? In the last lecture, we have to study the linear differential equation with constant coefficients. So, what is the linear differential equation? And find the solution of that differential equation when the roots are different and when the roots are repeated. So now also, if the roots are complex roots, then what is the solution here? Yesterday, we have to study when the roots are complex roots. When the roots are complex, say that is imaginary, so alpha plus I beta and alpha minus I beta are the imaginary roots, then what is the solution of the linear differential equation? So y is equal to e raised to alpha x c a cos beta x plus b sin beta x. So this is the solution of the differential equation when the roots are imaginary. Okay, so now we take here example. So what is the example? So example d cube y dx cube plus y is equal to 0. Solve this differential equation here. Solve here. So what is the solution of this differential equation? So by using the operator d, the given equation can be written as, the given equation can be written as by using operator d, so that is d cube. So d cube, so d is the operator plus 1 into y is equal to 0. So this equation can be written in this form here. Okay. So what is the auxiliary equation? The auxiliary equation is d cube plus 1 is equal to 0 here. So this is the third degree equation. So we solve this equation and find out the roots of that equations. So what are the factors of this equation? So this is a d plus 1. So this is a famous equation. D plus 1 is a factor into bracket d square minus d plus 1 is equal to 0. Okay. So this equation can be written as this. Okay. Very simple here. So that is d plus 1 is equal to 0 and d square minus d plus 1 is equal to 0. Okay. Therefore, d is equal to minus 1. So this is one root. So this is a second order differential equation, simply quadratic equation in capital D. Then there are two roots. So what are the roots? By using the formula, so d is equal to, so that is ax square plus bx plus c. Then what are the roots? Quadratic equation. So roots are x is equal to minus b plus or minus b square minus 4ac divided by twice a, using this formula. So here a is 1, b is minus 1, c is 1 here. So what is the roots? So that is minus b is minus 1, minus b is minus 1, so that is plus 1, plus or minus b square. So what is b? B is what? Minus 1. So minus 1 square, so that is 1. Minus 4ac. A is what? A is 1, c is 1, so that is 4. Divided by 2a. A is 1. So 2 into 1, that is 2 here. So this equal to 1 plus or minus root of minus 3 divided by 2. Divided by 2. So this equal to 1 plus or minus I root 3 divided by 2. Why I? Because the root of minus 1 is I. Root of minus 1. So root of minus 3 is root of minus 1 into root 3. So root of minus 1 is I and root 3 as it is there. Okay. So what are the roots of this equation? So d is equal to minus 1. Second root 1 half plus I root 3 by 2. And third root is 1 half minus I root 3 by 2. So these are the three roots of the this equation here. This equation. So what is the solution of this differential equation? So here one is a real root and another two roots are complex or imaginary. Then what is the solution? By using this formula. Okay. So this is a real. This is a real root. So therefore the solution is. So what is the solution? Y is equal to. So this is the third order differential equation. So it has three constant in the solution. So y is equal to C1 e raised to m1x. So this is m1. Okay, m1 e raised to m1x. m1 is what? Minus 1. So e raised to minus x plus what? So alpha plus I beta and alpha minus I beta are the roots. Then the solution is this. So these are the imaginary roots. So here these are also imaginary roots here. These are also. So what is this? So this is alpha plus I beta and this is alpha minus I beta. Alpha minus. So what is alpha? Alpha is 1 half. Beta is what? Root 3 by 2. Therefore what is the solution of this? So that is y is equal to e raised to alpha x into bracket something here. Okay. So what is e raised to? What is alpha? Alpha is 1 half. So 1 half into x into bracket. So that is, we take here constant. So what is, this is a constant C1. Then we take C2 instead of A. Cos, what is the beta? Beta is root 3 by 2. So that is the root 3 by 2 x plus B, that is C3. Sine, what is beta? Beta is root 3 by 2. So root 3 by 2x. So this is the solution of this differential equation. So this is a very simple equation here. Okay. So we solve the differential equation, linear differential equation with constant coefficient when the roots are different. So that is the first type. Second type is what? When the roots are repeated, then what happen? And third, when the roots are imaginary, then what is the solution of differential equation? So now we study here linear differential equation. Linear differential equation with constant coefficient. And a second member is a function of x. Member a function of x. So what is the linear differential equation? So we consider here so what is the linear differential equation? D raised to n plus p1 d raised to n minus 1 plus p2 d raised to n minus 2. Okay, plus and so on. Pn y is equal to x. Okay, so this is a linear differential equation. So what is x? Capital X, right hand side, this is a function of x only, small x or constant. So in the previous lecture, we solve this differential equation when we consider this is 0. We consider this is 0. If this is 0, then what is the solution? Then the roots are different, roots are imaginary, roots are repeated. We consider here right hand side 0 and then we find the solution. If this is not 0, then what happens? What is the solution? If this is not a 0, then what is the solution? Then the equation, okay, we find the solution considering the function of x, that is capital X here. Okay, so the equation, this is equation number 1. So this equation can be written as f of d y is equal to x. Okay, f of d y is equal to x. So what is f of d? This is a function of d. F of d means this. So f of d is what here? D raised to n p1 d raised to n minus 1 plus p2. This is f of d. p2 d raised to n minus 2 plus and so on pn. So this is f of d. Okay. So then what is the complete solution of this differential equation? Therefore the complete solution is the sum of complementary function and particular integral. So what is the complementary function and what is the particular integral? So adding those solutions, we get the complete solution of this differential equation. So what is the complementary function? So complementary function, so in short, we write here E C dot F dot. So this is the complementary function. So what is the complementary function? So it is obtained by solving what? Auxiliary equation. So what is the auxiliary equation? So this is equal to 0 here. P1 d raised to n minus 1 plus P2 d raised to n minus 2 and so on Pn. Okay, is equal to 0. Solving this differential equation, whatever the solution get is called a complementary function. So we take here 3 examples. We solve this and we get, if we get roots and the roots are different, then what is the solution? This is also complementary function. If the roots are repeated and we find the solution, this is also complementary function. If roots are imaginary and we find solution, this is a complementary function. When considering 0, so that is right hand side. If we consider right hand side 0 and find the solution is called complementary function. So what is the next part? Next part is particular integral. So in short, we write here pi. Okay, what is the particular integral? So since f of d y is equal to x, f of d y is equal to x. So what is the pi? So particular integral is equal to 1 upon f of d y. So just what is pi? Pi is equal to particular integral is equal to y. Y is equal to 1 upon f of d x. F of this x. So what is f of d? F of d is an operator. F of d is an operator. Then what is the 1 upon f of d? F of 1 upon d, f of d is also operator. So if what is f of d? F of d is a derivative operator. So f of d is derivative operator. simply derivation. So what is the f of d? 1 upon f of d. F of d is a derivative operator. So 1 upon f of d, d is an integral operator. Integral operator. Integral operator. Integral operator. So here, this is a particular integral. So how to find a complementary function of this equation? And what is the particular integral? We consider x. In this complementary, in a complementary function, we do not consider x. So x is 0 taking. But in particular integral, we consider x. So this is f of dy x. Okay. Then what is the particular integral? So y is equal to 1 upon f of dx. So then f of d is called derivative operator. 1 upon f of d operator on x. So this is an integral operator. So what is the meaning of? What is the meaning of 1 upon d? Just okay. Just meaning of 1 upon d. So what is the 1 upon d? Since d is a derivative operator, so we discuss about that derivative operator. Simply taking d here. Then what is 1 upon d? So 1 upon d is integral operator, integration operator. So what is 1 upon d? So 1 upon d is operator on x. So this is nothing but integration of x dx. Very simple. Very simple. So 1 upon d is nothing but integration. D is a derivative, capital D. Then 1 upon d nothing but integration. So for example, we take example. So what is 1 upon d? X. Simply small x. Capital X is a function of small x. So this is integration of x dx. So this is x square by 2. So we take 1 upon d square is operator d square. So d square, d raised to n and so on. So 1 upon d square x is equal to 1 upon d into d square means 1 upon d into 1 upon d. So x, this x. So this is what? 1 upon d. So what is 1 upon d? X. By using this definition, 1 upon d x is integration of x dx. So this is what? 1 upon d. So this is x square by 2. Integration of x dx is x square by 2. So again we take integration because 1 upon d is operator, integral operator. So 1 upon d x square by 2 is 1 half x square dx. So then what happened here? So this is 1 half. And this is x cubed by x, integration of x square is x cubed by 3. So this is x raised to 3 divided by 6 is the solution of this. So these are the derivative operator and integration of operators. So we study a very important formula, and what is the meaning of 1 upon d minus e. 1 upon d minus e. Okay. So what is the meaning of 1 upon d minus a? What is the d 1 upon d minus a? What is 1 upon d minus a? You learn what is 1 upon d. But what is 1 upon d minus a? So there is some meaning is there. Before that, what is, we have to find the value of 1 upon d minus a into x. So let us consider, let us consider first order differential equation. So we consider first degree differential equation. So that is dy by dx minus ay is equal to x. So this is a very simple differential equation. First order, first degree differential equation. So how to solve this? So this can be written as, so by using operator d minus a, y is equal to x. Very simple. Okay. So this is equation number, I think, so this is something a and this is equation number 1 here. 1. Okay. So what is the auxiliary? So how to solve this differential equation? So what is the auxiliary equation? So what is the solution of this? Solution of this is complete solution is the complementary function plus particular integral. So we have to find here complementary function. Therefore, the auxiliary equation is. So we consider x is equal to 0 to find auxiliary equations. So the d minus a is equal to 0. So d is equal to a. So therefore what happened? D is equal to a is the root. So therefore complementary function means solution is what? Solution of this is CF is equal to C1 e raised to ax is the complementary function. Means one part of the solution here. So now we consider x. This x. Then what is the particular integral? So now pi. Now particular integral pi is equal to what? 1 upon f of d x. We study what is this? What is the definition of this? So 1 upon f of d. What is pi is equal to 1 upon f of d x. But what is f of d? F of d is this. F of d is d minus a. So this equal to 1 upon d minus a x. D minus a x. Therefore, the solution is, complete solution is what? So y is equal to CF plus PI. So what is the PI? And what is CF? CF is what? So this is C1 e raised to ax. So plus, what is the particular integral? PI is this. D minus a x. Okay, so this is equation number 2 here. Okay, so this is the complete solution of this differential equation. But what is this? So what is this? So now we have to solve again and find out the solution of meaning of or formula of that 1 upon d minus a into x. So this is a solution of this differential equations. So what is the next part here? So this is a very simple. But the question 1, this equation, but equation A, this equation is a first order linear differential equation. Is a first order linear equation. Okay. Okay, first order linear differential equation. So what is the solution of the differential equation? What is the solution? So this is so you have to study what is linear differential equation and how to solve that differential equation. So how to solve that? So before that, find out integrating factor. So what is integrating factor? So that is IF. So what is P here? So this is, we compare this equation is equal to dy by dx plus py is equal to q. Okay, we compare this equation with respect to this equation. So what happened here? Dy by dx. What is p? P is minus a. And what is q? Q is x. Okay, so the integrating factor is e raised to integration of p dx. P dx. Okay, what is p? P is what here? Minus a. So e raised to p is minus a dx. So this is e raised to minus ax. So this is integrating factor. Okay, integrating factor. So what is the solution of this differential equation? First order linear differential equation. So the solution is what? The solution is y into integrating factor e raised to p dx. So we know the formula. So that is integration of this integrating factor e raised to integration of p dx q dx plus c here, integrating constant. So what is this? E raised to integration of p dx. Integrating factor is e raised to minus ax. So this is e raised to minus ax is equal to, so again integrating factor e raised to minus ax. And what is q? Q is what? Q is x. P is minus A, Q is X. X dx plus C. Okay? Okay. So then, we multiplying this equation by e raised to x. So this is y is equal to e raised to x. E raised to x multiplying by e raised to x. To this equation throughout. Then what happen? E raised to x, e raised to x, e raised to minus a get cancelled. So this is e raised to ax. E raised to ax. Integration of e raised to minus ax, x dx into plus again multiplying this term also for this term also, so that is c into e raised to ax, multiplying by e raised to x throughout this equation. So we get this here. Okay, e raised to ax. So now compare, so this is equation number 3. So from equation 2 and 3, from equation 2 and 3, from equation 2 and 3, what is equation 2? So solution of this differential equation is this also, solution of this differential equation is this also. Okay, so now compare that equation 2 and 3. So comparing this and this. So that is something c e raised to x is here. Then what is 1 upon d minus a x is equal to what? So this from equation 2 and 3. So just see here 1 upon d minus a x is equal to what? E raised to ax. Integration of e raised to minus ax x dx. Yes. So y is here. So this is here and this equal to this we write here. So this is the meaning of 1 upon d minus a operate on x. So this is the meaning. So this is a very important formula here. Okay, important formula. Similarly, we can find also what is 1 upon d plus a. D plus a is equal to, we obtain easily. So what is 1 upon d plus a? X. So that is here minus sign, we take here plus. So here plus, we take here minus sign. You can find easily here by using same method. So that is here plus, then opposite sign here. So here minus, then e raised to plus ax. X dx. So this is the meaning of 1 upon d plus a x is equal to this. So this is very simple. Okay. So we take example by solving using this formula. So what is the example here? Very simple example. So solve, evaluate. Example, evaluate. So I request you here. So the examples on this type we take to the next lecture. So we now stop here. Thank you.